your genius at an early age. What else can I say about him? He was fascinated by Gödel, by Hilbert's challenge to find a procedure that, in a sense, you could mechanically churn out all possible theorems and prove that they were consistent. That would be impossible to churn out two theorems that were one being the contrary of the other, like X and not X, and from a set of axioms that are powerful enough to give you arithmetic and math. And of course Gödel absolutely destroyed that challenge in 1931, and I will give courses on Gödel's work. Absolutely fascinating stuff, with implications, well, just enormous. Anyway, so Turing was fascinated by Gödel and Hilbert's challenge, so he started thinking about it, and one aspect of Hilbert's challenge was to find a procedure, some way of having a machine effectively make decisions on whether, you know, a particular conclusion could be generated from certain axioms. So Turing thought about this, imagined himself as a computer. Now remember, in those days, you know, this is before there were computers as we know them today, but computers in those days were people. They were human beings, usually women, who had an adding machine, and they would compute with the adding machine. You know, and so he imagined himself being one of these people, and you know, wrote down a list of tasks that the human computer would do, and then simplified it right down to the bare essentials, the essence of what it is to compute. And out of that distillation, if you like, shrinking things right down to the real essence of what it is to compute, out came the Turing machine. Now, of course, he did not call it the Turing machine. In fact, he called it the A, little a, first letter of the alphabet, the A machine. A standing for automatic, but very quickly other people were, you know, so impressed by it they just labelled it the Turing machine, and it stuck. So the whole world now knows the Turing machine as the Turing machine. Okay, but as a bit of history, Turing himself labelled it the little a, you know, the A machine, automatic machine. Now, if you want to know a bit about the life of Turing, I can show you here a few books. Turing was gay. He was a homosexual, and in Britain in the 50s that was against the law, as it still is in some African and Arab countries, unfortunately. And eventually the British government found out about this. Given the role that Turing played in cracking the Enigma code, that was the secret code used by the Nazis, the Germans, in the Second World War. So some people claim that Turing, in a sense, helped Britain win the war. So, you know, he had a lot of state secrets, and when the government realised, you know, that he was gay and hence bribable in the time, the climate of the times, they gave him a choice. You can, you know, with the thinking and attitudes of the times, you can go to jail, or you can take female hormones, because that was the belief, change his sexual orientation, and then his sexuality would be conventionally heterosexual, and therefore much less bribable. He would be much less of a state security risk. Okay. Well, he did, and he started growing breasts, and his brain just went to mush. He couldn't think, and he eventually just suicided. So the British government killed off one of its best brains, one of history's tragedies. Anyway, so here I'll give you the best one first. Well, my view, it's, you know, it's proper book length. It's what, 2 centimeters thick. It's called "The Man Who Knew Too Much." Right? That's from the point of view of the government and all the secrets in in the head of Turing. Alan Turing and the Invention of the Computer. The author is David Leavitt. Published by Norton. Now I have some shorter ones. Oh, well, there's two of them. The history of the role that mathematicians, particularly logicians, mathematical logicians like Gödel, the big one, of course, Church, Clean, Post, P-O-S-T, and others, played in the creation of the general-purpose programmable computer. Now here are two books. They're the same book. I think maybe one is the British version and the other one's the American version. So one's called Engines of Logic, Mathematicians and the Origin of the Computer by Martin Davis, published by Norton. And the other one, it's the same book, retitled, The Universal Computer, The Road from Leibniz to Turing, again, Martin Davis. So Turing features pretty heavily in both, well, in this book. Okay, so, and a few other short little ones on Turing. Turing, Alan Hodges. Who's the publisher? Routledge. And The Big Idea, Turing and the Computer, published by Paul Strathern, I think is a philosopher. And who's the publisher? Arrow. Okay. So reading the biography of Turing is fascinating. He's a very interesting guy. One of my heroes. Incredibly creative. Next chapter we will come across something called the halting, to halt, to stop, the halting problem, and the way that Turing proved, well, the result in this context was utterly ingenious, and take my hat off to him. All right. So the Turing machine, the actual design. So it's much more powerful than the previous two. Turing invented it in 1936 when he was 23, 24 years old, a young man. This new model, this third model we've talked about, simply just called the Turing machine. As I mentioned, Turing himself called it an A machine for automatic. Right? Now, the Turing machine is actually quite similar to the finite automaton. In the sense, it has states, right? So the Turing machine also switches from state to state, just the way a finite automaton does. It'll have transition functions, just the way a finite automaton will read a symbol on the input string, and depending on its current state, will then switch to another state. Well, the Turing machine, I'll tend to just talk about the TM because I'll be using this term Turing machine so often because it's sort of like pretty well the dominant theme for the whole text now. The previous two chapters are really just a lead up to the Turing machine, which is sort of the dominant theme. And the dominant part two of the text on computability is really about the limits, the power and the limits of the TM, the Turing machine. So I'll use this term TM a lot. Okay, so get used to it, right? Okay, so the finite automaton has real limits. Now the Turing machine, the TM. It's not finite. It can put information. I'm getting ahead of myself a little bit. It can store information not on a stack, but on a tape. So imagine. What if I have it here? Yeah, I do. All right, I'll just here. This is by now. This is just toilet paper. Okay. Now I don't know if you can see the perforations. It's two layered, so I'll just take off one. You can see now. I don't know if you can see the perforations here. So this toilet paper is divided into squares. So imagine this strip of toilet paper continuing on left and right infinitely, and you could call that strip. Well, it's not a strip anymore. Just call it a tape, okay? And on each